Hello, my name is Raunak Sharda, and today I would like to talk to you about Mars rovers, my GT project. Many robots have different sensors, threads, and robotic functions. I'm conducting this experiment to see which best combination of sensors, tire threads, and robotic functions will be the most efficient in time and will create the best rover. My final product will be an EV3 robot modeling a Mars rover with all the key components that work the best in my experiment, and an essay persuading NASA to send this modeled rover up to Mars. Question, variables, hypothesis, and materials. My question is, what components of a Mars rover make it more efficient in time? The independent variables are all the components of a Mars rovers. They will be tested individually and are as follows: tire threads, sensors, and robotic hand. The dependent variable is the time in seconds. Controlled variables include surface, EV3 rover, temperature, location, the altitude, rover's mass, rover speed, and the code on the computer. I have three different hypotheses. I predict that the symmetrical threads will help the EV3 robot be fast and more efficient than the bar grip threads. I predict that the ultrasonic sensor will help the EV3 robot be fast and more efficient than the light sensor. I predict that the robotic hand will help the EV3 robot be fast and more efficient than the rover without the robotic hand, also known as the normal EV3. The materials needed for this experiment are one EV3, a few rocks, one tape measure, a level that is smooth, such as a floor tile, and a notebook and pencil to record data. Also, I will be using a track for my EV3s. The EV3 will stand at the start. 5 feet away from the EV3 would be a pile of rocks. The EV3 would have to go around the rocks and come back to the start for the tire threads. For the sensors, the EV3 would have to go to the rocks, identify that the rock is there 5 inches or the color of the rock, and then come back to the start. For the robotic hand, it works a little bit differently. Types of tire threads. I did a lot of research on tire threads and I found two that I will be using on my rover. Symmetrical threads are found in most non-high performance cars because it is typically quiet and long-lasting. Bar grip threads are found mostly in military cars and off-road vehicles, and they wear down faster than symmetrical threads. The procedures I used to conduct the experiment are as follows. This is the data that I collected. The symmetrical threads were faster than the bar grip threads on average by 0.08 seconds. The code I used is shown. I used the LEGO Mindstorms Education EV3 classroom. Threads conclusion. After testing both tire threads, I have concluded that the symmetrical thread is the best tire for this robot. This is because it is faster than the bar grip thread by 0.08 seconds. This is a very small number and it should not make a difference. However, I have found out that symmetrical tires rotate better than the bar grip tire because the surface area of the tire is touching the ground more. The bar grip tire may be great for rocky terrain, but the symmetrical tire is faster and more maneuverable. It can also better handle sharp turns. This is probably why most of the Mars rovers have symmetrical tire patterns. Types of sensors. I did various research on the types of sensors. I found two types of sensors that I will compare, the ultrasonic sensor and the light sensor. The ultrasonic sensor would measure the distance between an object and the rover. The light sensor would identify the color of the object. The procedures I have taken to complete this part of the experiment are shown. Here's the data that I have collected. The ultrasonic sensor did not touch the rocks at any point in time, and the average time in seconds was about 8.45. The light sensor did touch the rocks twice, and it took about 9.15 seconds on average for the light sensor. The ultrasonic sensor and light sensor codes are shown on the screen. Sensor conclusion. I conclude that a robot rover should have a sensor that identifies any object in a certain range instead of the color of the object. I conclude that the ultrasonic sensor is better than the light sensor because the ultrasonic sensor will give an accurate reading every time and will not rely on color. Color can change based on the color contrast inside of the room and the shades of color, since not all rocks are the same. The ultrasonic sensor, however, will only measure in distance, which will be the same every time, making it more reliable than the light sensor. Robotic hand. I have done lots of research on robotic hands and how there are different robotic hands in different Mars rovers. I will be using the touch sensor found in the EV3 Mindstorms kit to represent the robotic hand. The track for this one will be different, as the rover with the robotic hand will touch the rocks for about a second and come back to the start, while the rover without the robotic hand will have to go around the rocks, just like the other trials. Remember, the rocks are 5 feet away for each trial for any of the independent variables. The procedures are shown on the screen. Here is the data that I have collected for the robotic hand testing. The robotic hand had an average time of 9.27 seconds, while the EV3 without the robotic hand had an average time of 12.25 seconds. The EV3 without the robotic hand is the same data as the symmetrical threads data. The code was also shown in the previous screen. Sorry. The robotic hand conclusion. I conclude that having a robotic hand is beneficial to a rover because it decreases the time the rover needs to view and collect data of Mars rock, dirt, or other mysterious things. As you can see from the data I have collected, the rover with the robotic hand is faster than the rover without the robotic hand. This is true even though the rover with the robotic hand did touch the rock for 1 second. My finished product is a rover that I created from all of the components that worked the best in each of the 3 categories: symmetrical threads, ultrasonic sensor, and touch sensor, aka robotic hand. I have also sent a letter to NASA. Here is the letter. This is my bibliography. I have used 5 sites to collect my research and data from. Thank you so much for listening to my presentation, and I really hope you enjoyed it. Once again, my name is Raunak Sharda. Thank you.